Hello. I've had quite the summer. I managed to get some pretty awesome things done, and now I'm going to talk your ear off about them. This summer, I managed to get a fantastic internship with Komatsu Mining Corporation. You might see Komatsu branded construction equipment around, but not many people are aware that they have a massive mining division as well. It makes a lot of the best mining machines and solutions available, and I'm really proud I got to work there. I worked for engineering services, and my duties primarily involved writing code to make everyone else's jobs easier. There's a running estimate somewhere out there of exactly how much time I saved with the apps I wrote, and it's definitely over 1,000 hours by now, maybe even 2,000 by this point. I'm really proud of that. I did obtain a slight case of a carpal tunnel while working there, but it's nothing too big. In the evenings and on weekends, I worked hard on a new Nerf blaster design. I was really excited about it. It would strap to your arm and have a microcontroller on it and have an LCD screen on board to tell you how much ammo you had left and all sorts of different features. I was planning to post bi-weekly updates on this channel as I made leap after bound in progress, and it was going to be great. As you can tell, I am sometimes an idealist instead of a realist. This is the story of how things didn't go to plan and how I've persisted and prevailed. This is the story of how I solved problems and proved to myself that, at the end of the day, I truly am worthy to call myself an engineer student. Every so often, after work or on weekends, I'd sit down at my home desk and open Fusion 360. I want to try Onshape sometime, not sponsored. Don't sponsor me, I'm not a professional video maker, and I don't want to be. Because I'm using Fusion 360's student license, and that's going to run out soon. But in the meantime, it'll do. Now, I'm a computer engineering student, not a mechanical engineer, so my modeling strategy mostly involves making it up as I go along and hoping I get lucky, and I like it that way. I will learn by doing and by my own mistakes, and it's okay when I mess up because it teaches me lessons I can use to improve for next time. Let's just say I learned a lot. The first step was to purchase my components from online. I'd need 2 motors, a solenoid, which is basically an electric box that pushes a rod when it's powered, and a couple flywheels. Fortunately, I know a couple online hobby shops where I can get those. Once those arrived, I was immediately paralyzed with fear because I'd realized I'd need to do some really finicking and precise modeling to fit all these exact components in a location, precise to the last millimeter. It took a good while to get the motivation to get started. While I procrastinated, I asked around online if anyone had any tips. And then someone linked me to a printables page where every conceivable configuration had been done for me ahead of time. And further was available to download as a Fusion 360 file, meaning I could import it into my designer and get modeling around it. It took the exact motors I had purchased and the exact solenoid I happened to get and had a configuration for the exact flywheels I had bought. It was proof that fortune was on my side, no matter what. Anyway, I got to modeling over the next couple weeks. I took it slow because the last thing I want to do is get burnt out over this project. It's difficult to model sometimes too. I've learned that once I get into a groove, everything will just fall into place. But if I don't, then it'll take hours just to decide what part goes where. At last, I made the completed model. And then I had to turn to the wiring. I was given a microcontroller for my birthday that I wanted to use for an anode counter for this project. So I plugged that in and discovered that an OLED screen was also included in the kit. So I wired that up for a quick demo. The results were extremely promising. I had a lot of fun with it. Next was the soldering of the control boards themselves. I just bought a pile of blank PCBs and a couple other odds and ends I could get on the cheap for in bulk. And then I sort of winged it when I soldered this thing up. I like to consider myself fairly good at soldering, so if you guys make fun of me for my bad joints in this job, I blame it on my father's old soldering iron that I had to use. The tip was completely damaged and I had to get a replacement. That replacement hadn't come in yet when I soldered this board, so I made do with what temperatures I could get out of this thing. I think it turned out pretty well though. Next, I wanted to test the board, so I charged up my battery. A quick note about these batteries I'm using. They're known as a 3S LiPo, and they are very good at being a high voltage battery that's pretty lightweight. The only downside is that they're somewhat volatile and easy to permanently destroy. They're also expensive and I only have 2. So I had to be absolutely sure that this test would work. If things shorted out or caught fire, that would really suck. Especially since the battery would emit smoke that could dissolve my lungs. Anyway, I took it outside and tested the wiring, and it worked. All I had to do now was hook up the microcontroller, print out the rest of the parts, and I'd be good to go. Hooray. One issue. The battery ran on 12 volts and my microcontroller ran on 5. And I really didn't want to fry my microcontroller. It has sentimental value to me. Fortunately, I had foreseen this issue and bought a special chip that would allow me to step the voltage to the microcontroller down to an acceptable level. It's this one right here. So I soldered that in and decided to test it again to see if it would work. And I'm glad I did test it. When I ran some power through it, the chip fried instantly. It's my fault for not putting some resistors in here since I was pumping one heck of a current through it. Anyway, this board wasn't going to work, and at this point I decided that maybe I'd set my sights too high. I decided to remove the microcontroller and the screen from the project entirely, and go for a more analog build, at least to start. If at first you don't succeed, move the goalpost until success is what you've already done. Anyway, I soldered up a new board and then got to printing the shell of the blaster. All of the other stuff on my channel was made to be low hardware, but since I had already bought so many electrical components, that goal of mine was out the window instantly. So I got off my lazy butt and taught myself how to add screw holes to my parts. It was actually stupidly easy. Fast forward to about midsummer and I had everything printed. I was so excited to strap it to my arm, and this was heavy. Too heavy. To stop it from slipping, I needed to strap it to my arm so tightly that my hands started to turn purple. And even when I did have it on, I couldn't hold out my arm to aim it without feeling dangerous levels of torque on my shoulder. If I did take this to one of my Nerf events and someone runs in my arm, my shoulder's gonna twist right off. So I scrapped the whole thing. I still love all the parts right here too. No hard feelings either. I modeled to teach me my mistakes, and this is why we make prototypes, so we can find these things out. The arm-mounted Iron Man blaster thingy just wouldn't be feasible in this configuration. I wasn't done yet, and I still had time before college to get something to show for my efforts. New model, new control board, new challenges, new successes. I'll spare you the details because sometimes even I get tired of talking, but to make a long story short, here it is, my new blaster. I call it the Scion Mark I. I just finished it last night. I'm very proud of it. I'll show you guys some test footage of it now. And I think I'll end the video after. I'd give you guys some closing remarks, but that's what a good YouTuber would do. And so, out of principle, that is what I will not do. Only the lowest of quality here on the Octocat channel. I upload what I want, when I want. Alright, this is the combat test for the Scion Mark I. I spent a long time on this. I really hope it works well. Yeah, I'd say the results are pretty conclusive. That's a lot of fun.